how do you solve this error in Python which says no module named sklearn? So you might be tempted by your knowledge of Python packages to simply install this package by using the following method. So you will copy that name over here and then go to view, and then under view, select the terminal option. When you select the terminal option, you wait for the Python environment to activate over here, and then you will simply do pip install and then paste in the sklearn that you copied from there. So if you were to do that, so if you were to paste that in pip install sklearn, what you will see is it will try and install it, and then you will suddenly get an error message over here to say that the sklearn failed to build when getting the build wheel. So this is important to understand, because if you read the error message that you get, so it looks a very strange message. It says subprocess exited with error, but what you need to do is read through the error, and the error actually tells you what you have done wrong. So the sklearn package has been depreciated. Instead, what you need to do is use this one, sklearn or scikit-learn. So rather than use sklearn, you need to use this command. So it even tells you, actually, Python is very helpful. And it tells you over here that you need to install using this command over here. So the command is this one, which is one we used, but the actual command that you do need to use is this one over here. So what we'll do is we'll simply copy this command. So Control-C on your keyboard. And then what we'll do is we'll run that command over here. And you can see that it's installed our sklearn package. So now what we can do is we can close the terminal by clicking here. And if we were to run our code over here, and you can see we no longer get an error message, and this is running. And then you can see it's run successfully, and it's given us the mean squared error. Hello everyone. As part of machine learning, you need to understand classes. So my aim is to take you through understanding classes step by step so that you fundamentally understand how classes work. So what is a class? A class, as you can see here, is declared with the class keyword. Now notice here, this keyword is very important to understand. It needs to be in lowercase. So you cannot, for example, do this. This is very important. So Python will not like that. It wants the word class to be in lowercase. Then you give your class a name. This can be anything that you want. But in this instance, we called it a dog. You can make it lowercase, but the preference is that it should be uppercase. Now here, you can see how the uppercase and lowercase matter. If you define this as lowercase, then you can see an error to say dog is not defined. So that doesn't seem to work. So what you need to do is, ideally, classes should have an uppercase letter like this. And then when you hover over it, you can see this is a class because we use the class keyword. Now, the next one is you just put two dots here. These are known as a colon. These colons are very important because they mark the start of your class. So in the first line, if you were to take this apart, all it does is you give it a name to your class using the class keyword. The next keyword might look strange, but what it is, it's all in lowercase, and it's the word pass. Pass is simply a placeholder in Python. So what I mean by a placeholder, it's what you're going to write something in the future, but you don't want to write any code now. So for completeness, you just add the word pass. So this keyword does nothing. It just passes. So the code, if you were to not define this here, what will happen is, do you see you get the squiggly line, the red squiggly line? That means that your code is incorrect. So when you try and run this, it says incomplete input. So in order to resolve that, you just add a dummy keyword here called pass, and that just makes your code work. So this dog class is very empty. So it doesn't do anything. It's literally just the name dog, and it's a class. That's all we know. And then you can create an instance of this class by using dog with open parentheses, close parentheses. So you cannot do it like this. You have to do this. What the parentheses do is they initiate a copy of the dog class. So here, this class here, we're just creating a copy of it and storing it in this variable. Then when we run this code, you can see that it returns it's a class which is of type dog. Later on, I will explain what does this mean and what does this mean. So I hope you like this video so far in understanding how do you actually define a class. It's very simple. Just use the lowercase word class and name your class, 2 colons, and so far we'll just leave it empty, not get it to do anything. So we created here a simple class called dog, and this class basically, as I said, does nothing and has nothing in it. So we just included the word pass to comply with Python syntax, because if you were to take out this word, then you can see that we get this squiggly red line to say the syntax is invalid. So for completeness, we just add this dummy word pass. This is a valid Python keyword, and its purpose is to act as a placeholder so that your code basically works. So you don't have to type in what the class dog actually does. You can just pass it. Oh, I don't know the answer. Just pass, that sort of thing. So here you can see we are creating an instance of this class. So by creating an instance, one thing that you need to be aware is the terminology. So creating an instance of a class is basically using the class DNA. So we've got the DNA here. We are creating a living version of the class. So a living version of the dog. So we've got the dog's DNA. We know what it's made out of. At the minute, nothing basically. It's just pass. It's like a dog in, that doesn't do anything. But here we're saying, give us, using that DNA, create the copy of that dog, a living copy, even though it doesn't do anything. So when we do that, we then say, give us the type of that dog. What is it? What is it made out of? And you can see the type is, it's a class, because we've said it's a class over here. And you can see what it's here, where the weird syntax is: main underscore underscore main, and then underscore underscore, and then dog. Because this dog class is created in this Jupyter notebook, so you can see I'm in Jupyter notebook. Jupyter notebooks always run under like a main entry function. So that's why you get this main here. Now I want to show you a difference actually. If you were to create this in a separate file like this, so we've got the same thing, class dog, and we're just doing nothing with it, but this is in a file called animals.py. And then you were to import that in. So here we are importing in animals, which is that file there. And this is the dog class we're importing. And I've just shortened it DG to not conflict with that. And when we print its type, you can see it actually prints the file name. So this file is called animals, and we get animals.dog over here. And you can see this one is main.dog. And now you know why it's main, because it's not in a separate file. It's actually part of the main function for Jupyter Notebook. And that's where it gets created, while the other one is actually in this animals file. So that's why you get animals.dog, whereas here you get main.dog. So I hope this clarifies how you can see the type of a class, and that's how it's created. So just remember that here class is same. This is main because it doesn't come from any other file. It's just part of this Jupyter notebook. While if you were to import this in from the file here animals, then of course you will get the animals. Otherwise you'll get underscore underscore main dog, but here you get animals.dog because of the file names. So I hope this clarifies this weird looking syntax over here. So we are in this Python Jupyter notebook over here. And you can see we have created a class here called dog. And you can see this class at the minute does do nothing. So here it's just basically using the keyword pass. Pass is a keyword you use to prevent errors in your code while you are thinking about what to implement in Python. So if I were to take this out, you can see the usual, we get this squiggly line over here, which indicates there's a problem with your code. But if we add the word pass in, then Python says, hey, everything is fine. You've added the word pass. So you know that this class basically does nothing, or this piece of code does nothing. So that's where this is. So here, when we look at this, how do you create another class within Python Jupyter Notebook? So what we need to do is we need to add another class, and you can do it in the same cell over here within Jupyter Notebook. So you could start writing the word class, and let's call this cat, for example. And we're going to use cat over here, and then we're going to use 2 colons. So these colons are needed. And then as you press enter, Python is all about indentation. Automatically indent to the correct place for you when you press enter in VSCode Jupyter Notebook. So what we'll do is we'll just use the word pass again. So now we have 2 classes here. One, which is a dog class. The other is a cat class. So you can see here, we are creating an instance of that class, of the dog one. But what we mean by instance is we are using the DNA of the class, which is defined here. So what makes up a class is over here. And we using that DNA to make a real dog out of it. So this is where this is happening. And this is called an instance of it. So basically we could create multiple instances. So just imagine you had DNA. It's a bit like dinosaur. If you've seen Jurassic Park, you can make clones of things of dinosaur if you had the DNA. So how do you create a class in external file rather than within your main code? So here you can see within the Jupyter Notebook, we have created a class called dog and a class called cat. And then what you can see is the dog class is initiated here. So this is an instance of it. And then an instance of it is created here for the cat. But how do you create a dog class outside of this code? So if you don't want it in your main code over here, how do you separate it out or use an existing class that somebody else has created? So if I were to run this code, so let me just run this code over here. So I'm going to click the execute button over there, and then I'm going to click the execute button over here. And one of the main things I want you to pay attention is this output that you get for the type. You can see that an important aspect of this is this main dot bit. So you can see main here is being printed because the classes that we're using, the dog and the cat, are part of this Jupyter Notebook, and they are within a method called main, which we cannot see. So they are living in the same file. So this is how you can tell which class you're using. You're using the one from the main file. But if you want to transfer that out, so this is what I've done, which is created a file called animals.py. And you can see I have stored this in a separate file. This file resides in the same folder as machine learning house prices over there. So that's the folder where I've put it. I wouldn't worry about the folder where you put it, but as long as it's in the same folder. And then you can see that in order to use this, what you can do is you can import that file in. So to import it in, you use the following command. So use the keyword from animals because that's what the file is called, and you're importing in the dog class. And at this time, I'm aliasing the dog class as DG because we want to differentiate it with this dog class over here. So that's why you add the alias over here. And then again, this is the same code as before, but notice DG because that's the alias. So we're calling dog as DG, and that is being created here. So an instance is being created here, and then we're going to print the output just to show you the difference. So if I were to run this code over here, you can see that the class type this time is no longer main, it's actually animals. This animal comes from the file name. So this is how you import in a class from a file that you have, and you can bring it into your code over here and use it within your code to create an instance of that class. So this file lives outside of that book, Jupyter Notebook. So in essence, you could get rid of your code over here and just use this file over here. And the way you can tell it's from an external file is because it will usually have this animal, while any classes that you create within your Jupyter Notebook will have main.cat, dog, or wherever your class name is. So in this instance, you'll see that it's actually called animals, which is based on the file name. How do you access a class from a subfolder? So here you can see in Python, I have created a class in this file over here. This file, if we have a look at the file explorer over here, you can see that my classes notebook over here, classes Python Jupyter Notebook, lives in this house prices folder. And in this house prices folder, there is a class called animals. This class is in the same folder as the Jupyter Notebook. So if we have a look at that, you can see that we can simply import in from animals, which is the file name over here, and we can import in the dog class because the dog class is part of the animals.py file. But what would happen if you were to import or put this class in a subfolder? How would that work? So if you wanted to rearrange your code and make it a bit neater, how would you make it work? So what you can do is in here, we will create a new folder. So we will click on this new folder button over here, and then we're going to name our folder. I'm just going to call it. So there you go. I've named a subfolder, and that folder now exists. This folder at the minute, you can see it's empty. But what we'll do is we will move the animal file into the subfolder by simply clicking on it and dragging it into this subfolder. And then we get this message to say, are you sure you want to move animals.py into the subfolder? And we want to click this move button to say yes. Then we get this message over here that says we do have a Visual Studio extension called Pylons, and it wants to refactor the code because the file that we are using has moved. So do we want to do that? So we could do that. So we could click on show preview, and you can see that it's saying that this is what the refactoring will do. It will call it subfolder.animals, but we'll discard this, so we won't do it like this. So we will ignore that. Instead, what we'll do is we'll do it manually so you can understand what's going on. So if you can see, it's saying import cannot resolve this reference. So Pylons cannot resolve it. So if we were to restart our kernel over here, and if we were to run this, you will see that it's saying module not found error, no module named animals. So what we can do is we can just simply call call that, so our folder is called subfolder. So we're going to record subfolder, and then we're just going to put dot in here. And that's now going to look into that subfolder. So that's the module. So what you may say as a subfolder, and then this is the module called animals. And in that animal file, the class called dog. So we will run this code now. And you can see that our class is subfolder animals.dog. So this is how you resolve the reference issue with subfolders in Python, and how you arrange your code into folders if you want in your code. How do you import in a module that's stored in a folder outside of your project? So this is how you do it in Python. So I will explain what this code does exactly and how do they actually work behind the scenes. So here you can see I previously had this animals.py file within the root of this folder. So I've got classes Jupyter Notebook over here, and this is stored in this house prices folder. But this house prices folder over here is actually stored in a file. If I hover over here, you can see it's actually in machine learning, house prices, and then classes.ipynb. So that's where this is stored. But I have this animals.py file, which is stored in machine learning. So it's not within here. So if I just show you what it looks like in the Windows Explorer. So here, what you can see is I've got Python folder, and then I've got machine learning, and within the machine learning folder, I have house prices. So if I open up this house prices folder, you can see that there is classes Jupyter Notebook. But prior to that, if I go back one level over here, and you can see I have a subfolder here, and in this subfolder is the animals.py. So now the location of this animals.py is actually within machine learning subfolder rather than house prices subfolder. So it's not at the root of the folder. So what we can do is we can use this command. So import the sys module, and then sys insert at position 0 the following path. So what this does is it will make that path available to your code. So if we have a look at this code over here, so if we print what the system path looks like, so if I print that, what you can see is a list of paths that the Python code will look through to look for modules. And you can see it starts off, looking in within the Python environment in 311 location. Then it looks at some DLLs. It keeps looking for these modules. It looks at eventually at the virtual environment over here, and then within these side packages. But when we run this command, if I run this over here and then run this again, what you will see is right at the beginning at position 0, so index 0 over here, it has inserted a new path. And this is the path that it will look for subfolder.animals. So that path becomes available to your code. So even though Visual Studio Code is complaining of an error, but behind the scene, it has added this path and made it available to your code. Whereas previously this path was not available. So that's why you would get a module not found error. So if I were to restart the kernel, and let's restart it, and if I comment out this line over here, then what you will see is you'll get an error to say it cannot find a module named subfolder over here. So module not found error. This is because this path over here has not been added and made available to your Python code. But if you uncomment that out, and it will insert it position 0. So this 0 basically means it will insert it at index 0 and may look for your code animals, subfolder.animals at the first thing. So if there are conflicts, if Python also has a package named animals, it will actually use your package rather than Python's. So if I run this code now, and you can see that the code works and we get the expected output that we want. So what is so special about this insert function? So sys path insert. What this is doing is basically inserting this file path into the places the Python code will look for modules. So as you saw in a previous example, we have this animals module or class that we created within this animals module. So we created a dog class, and this dog class, it lives in a folder called subfolder.animals. But this is at this location rather than within the location where our code is running. So when our code runs, you can see that this location is actually machine learning, house prices, classes. So that's where this file lives. But this one is located within the parent directory rather than the subfolder. So by you running this command, what it does is it makes that code which lives in this folder, machine learning folder, and then to the folder called subfolder, and then a file called animals. So in here, I can show you. So if I go to machine learning, there's a folder called subfolder, and within that subfolder, there is a file called animals. And if I were to open this up, so I've just opened this up, and you can see this is the location for it, and it has a class called dog and does nothing. So what this does is the insert part will actually insert this path at position 0. So when we run, for example, sys.path over here, what it will do is it will insert this at position 0. Now there's another option. You could use append. If I use append now on here, so I will use append and I will get rid of this index, which is not needed. So if I run this over here, you can see that append has been successful. And now if I print this, what you will see is it has added our machine learning towards the end. So when Python looks for modules, it will look for the modules in this folder last. Whereas if you use the insert option, which is insert over here, and then at position 0 over here, or index 0, then what will happen is it will move that into the first position. So if we run this, you can now see that machine learning has actually jumped up to position 0, but this is the first place Python will look for a module. So this would work in a situation where you have a conflict. For example, Python has a statistics class or module, and that module may conflict with yours. So what you can do is you can use this trick over here to make Python use your statistics module rather than looking in some standard places that it normally does. So here is a very interesting example with the sys path within Python. So this function previously we've used to bring in code from another folder, but what you can use it for is to override some standard modules or libraries in Python. We wouldn't recommend doing that, but in certain situations you may want to do it, but that would cause confusion. But I just want to show you this so at least you are aware. So here you can see sys path insert index 0. So what this will do is it will make this my code folder. So if we have a look at the Explorer, you can see I have a folder called my code. In that folder, I have a file called statistics.py. So this statistics.py is also available as a standard Python library or module. So when we import in statistics, which one will it use? Will it use the Python one, or will it use the one I have in the my code folder? So in this subfolder, and in this subfolder, you can see I just have a class called max, and it basically does nothing. This is just an example. So the point is that statistics.py exists as a module within my code folder. So if I run this over here, what you can see is this is importing in the module, and you can see it's called a module over here. And this module, when you print it, it tells you the location where it's coming from. So at the minute, it's coming from Python 3.11 library statistics. So this is the standard location. So it's coming from there. It's a standard location and standard package of Python. But I want to override this. So I don't want to use this standard location, for example, for whatever reason. And you may come across this code in production. Hopefully not, but you may do. And you don't want to be left confused. So if you were to look at this code, and if I were to just print this now, sys.path, but before I run that, I'm gonna run this over here. So I'm gonna run that, and you can see the locations of all the folders Python looks for. So if we have just a scroll of this, and you can see all the different location Python searches for the code, eventually it looks for within your own folders. But the priority is given to the folders here at index 0, index 1, and so on. So you can see it looks for that. So we are not surprised that we are seeing Python 3.11 location over here as a priority. You can see the lib there before it looks at our own folder and the virtual environment over here. So if I now change that and run this code to basically append at position 0, so that means over here, append it before this one, my code folder, which is over here. So if I run this, and then if I run the path over here, you can see that my code now is the first item. And then you've got the Python 3.11 location and so on. So you put the other locations here. So now what do you think will happen when I run this command? And you can see the statistics module is now being imported in from the my code folder rather than the Python 3.11 location. So we are basically overriding the standard location and bringing in a module that conflicts with the Python standard module and using ours instead of Python's. So this is a bit of a useful code to bring in external code and also override standard libraries and modules if you want.